Ta-ta, it's a pointless activity.
Oh, it's not pointless, because we might well find that there is life on Mars. This is something that might be settled in our lifetime. And the implications, I think, are absolutely staggering.
Possible, likely, big if, isn't it?
Well, of course it is, because we just don't know at this stage. But all I can say is that the conditions there were once favourable for life, and it could still be clinging on even today. But we don't know.
We'll find out, we hope.
There is, however, an even more extraordinary possibility. Suppose the next space probe to Mars does find signs of life, but that life is totally unlike anything found on Earth. Suppose it's a completely different life form.
If we do find evidence for life on Mars, and it's not related to Earth life, then the implications of that are truly stunning, because it means that there are two separate origins of life in the solar system. Life has arisen twice, quite independently. Now, 2 out of 2 in one star system implies that the universe must be teeming with life. It's just too much of a coincidence if it happened by accident just in one place, and the rest is sterile.
Extraordinary as it may seem, the possibility that there may be other life forms in the universe is now being taken very seriously. For some years, Davis has been following the work of an international project called SETI, the Search for Extraterrestrial Intelligence. One of the research centres involved is Jodrell Bank near Manchester. Here they're using one of the biggest radio telescopes in the world to peer thousands of light years across the galaxy.
Each night we spend about an hour to an hour and a half looking at a particular solar system, scanning across the range of frequencies where we suspect a signal might be found. So we just do one star, move to the next, then the next star, perhaps 5 or 6 stars a night, looking where we expect life to be most likely to be found. And that's essentially on planets around stars like our Sun.
The observations are made in the spring and autumn, usually at night, when there's less radio interference.
There are lots and lots of signals we pick up from space, some from natural phenomena, things out there in space. Many, of course, from transmitters on Earth, mobile phones, satellites, television stations, whatever. Now, we know the characteristics of all those signals, and that is not what we would expect to get from ET. So if we got a signal from ET, it would look very dissimilar to those, and that will enable us to say, yes, that really is it.
The project's limitation is that it's only capable of detecting intelligent life, familiar with radio technology, and the chances of finding that are very small. Yet the implications, if something is found, are so enormous, most researchers consider it worth the effort.
Even if the program is completely unsuccessful, we never ever detect any messages, and maybe even if there aren't any aliens out there, we've all had to think very seriously and very deeply about some profound issues. It forces us to think about who we are, where we fit into the galaxy and the universe beyond. Who are we?
One critical piece of information could make this search easier. It's the million-dollar question that is still a total mystery. If we knew how life was made, the precise combination of chemicals and physical conditions, we might be able to predict where it might occur. Most scientists now agree that the chances of it happening as a random accident are extremely unlikely.
The chances of life forming by accident just from the random shuffling of the molecular building blocks has been estimated as a stupendous 10 to the 40,000 to 1 against. That's 1 followed by 40,000 zeros, enough zeros to fill an entire chapter of a book. It's a bit like putting a stick of dynamite under a pile of bricks and exploding it and expecting to get a house. Well, you wouldn't get a house, you'd just get a mess. I think that there is some scientific principle to be teased out that will show the way it was done. But at this stage, I think it's a complete mystery for how life got started.
Let me take down this flask here.
At the NASA laboratory in Mountain View, Chris McKay is also trying to understand what these principles might be.
With a combination of simple gases, you can make organic material. So this could have been happening on the early Earth.
And you use electricity to make the reaction go.
That's right.
A bit like Frankenstein.
Exactly.
He's put some of the basic building blocks of life into test tubes and is exposing them to different physical conditions.
What we're finding is that it's easy. The organic molecules that make up life come out naturally from a mix of simple molecules. The hardware of life is easy. What's hard in terms of life is the software. By the software I mean the instructions that are in the DNA, in the genome, that tell life how to reproduce, how to produce itself, how to make the form. This is the real essential mystery of life. If we think of life as a hardware component and a software component, it's easy to find silicon. But a computer is not just a bunch of silicon thrown on a pile. It's got a particular structure, and that structure is most clearly represented in the software in the computer. So, to my mind, that is now the essential problem in the origin of life, is how can we get the software integrated with the hardware. We know the hardware is easy, we know it's going to be on any planet, Earth, Mars, wherever. The question is, how did the software get in there? How did the instructions, the information get into biology?
To add to the complexity of the problem, if, as scientists now believe, the planets in our solar system were bombarded by huge meteorites for millions of years, then it's possible life may have flickered into existence and been extinguished several times.
One of the implications of these large impacts that are capable of killing all life is that life might have started on the Earth, and then a large impact might have killed it, and then small material, organic material, could have restarted it, reseeded the process, life starts again, maybe then gets wiped out again by another large impact. So there could have been many origins of life on Earth, followed by many global extinctions of life.
If McKay is right, then there may be more than one method by which life got started. Somewhere, buried in the universe, there may even be the remains of one of these earlier life forms. The problem for Davis is that the record on Earth is just too slender. It may be sufficient to tell us when life started here, but there's simply not enough data to tell us where it started. And until that's solved, it's probably impossible to know how it started.
The how part, now that's really, really tough. A lot of people make upbeat statements. We'll very soon make life in a test tube. We'll understand how it all happened. I think we're a long, long way from knowing how Mother Nature did such a complex and ingenious thing without a lab full of chemists.
Certainly, Davis is pinning his hopes on future Mars missions to solve a problem which is probably insoluble on Earth.
I have a hunch that the solution to the problem of life on Earth, the secret of life on Earth, will be found on Mars. I think if we could go there and just find even traces of past life and relate it to Earth life, we're going to get absolutely crucial clues that simply have not survived here on planet Earth and could not be reconstructed in the lab in a million years.
Davis is convinced the answer may not be that far off.
I foresee a decade or two of intense activity and excitement where we really do begin to unravel not only the physical basis of life, but its conceptual basis. We understand not just how life works, but what it is and how it's put together.